Hello everyone, welcome to the third stream about making the animation blend state machine editor. And today we are gonna be doing something different because I found a problem which will probably be a bit annoying for for the editor because if you remember the previous streams, I made a special canvas that is able to zoom and like drag the view, and it works by doing this, basically changing the position and the size of the nodes, but it will not work correctly. That happens because it changes the position in local coordinates, and it doesn't really scale anything. So this zoom factor is actually changing the bounds of the node. It does not scale it as an image or as a picture. So this is undesirable. It's an undesirable effect, and we have to change that for true zooming and scaling and offset and this stuff. So as you can see, the size of the font remains the same, even the node are small. So why is that a problem? This is a problem because when we'll have the sockets on the sides of the nodes, they're usually just circles. When we zoom out this, it will like overlap, and it will be a total mess because they will not scale correctly. So, and to fix that, we have to go to the UI library, to the Fyrox UI, and basically add the missing functionality there. And that functionality involves the two transforms. So the one transform is render transform that is applied before rendering the UI on screen, and the other transform is the one that is applied to the layout. And the layout transform, basically what it does, it just changes the available size. At the measure step, it changes the size of the node that was measured. It changes it, it scales it, and so basically you could imagine a rectangle, and we can like rotate it 45 degrees clockwise. And let me show that in this editor. So for example, this is the widget, right? And its bounds are like are the same as the bounds of like this black rectangle. Okay, but if we will rotate it, I don't know if this editor can rotate it 45 degrees. Probably it can't. So maybe I should go to, where is that? Probably the Inkscape would be better because it's an all right, let's create a new one. Yeah, that will be a better illustration. So that's our widget, and if we'll rotate it 45 degrees, as you can see, the outer bounds has increased. And that means, and that is what I mean by layout transform. So the rotation and scaling will change the size of the widget. So also the layout transform will affect the rendering. It will be combined with the where is that? With the render transform. If it's identity matrix, then there will be only layout transform. And where is that? And if we will have layout transform something different from identity, then the renderer will receive that transform too, and it will create the rotated widget. So this is not so simple because we have to modify basically two things today. One thing is a let me check. That should be the control trait. Maybe not the control trait. There should be a measure node. All right, it's here. So as you can see in here, it overrides the arrangement and measure by the two methods. But in here, this is the core measurement method, which is inside the UI library. And what it does basically, it prepares the size and stuff and calls the custom method of measurement. And the custom method always involves this like subsequent calls of measure node of the children, and there could call that in call that too, and yeah, basically the depth traversal of the tree. And yeah, and it returns desired size, so we have to modify the desired size after the measurement is done. We only need to modify the size, so that basically means that the layout transform won't affect the location of the widget at this stage, but it can affect the location at the arrangement stage. So basically, the arrangement returns the arrangement sets the position and the size, the final size of the widget, and we should modify that in here too after the call of the arrange override. So we should get the transformed final rectangle, I think. And I do have WPF source code, which will help us today, because it is a bit annoying to invent the wheel from scratch. That this is basically the invention of the wheel, and we should just take the approach from the source code because it's free and there's no problems with that. Basically, we'll adapt it. We will not take the as is. We will adapt it to this. So they are very similar. The WPF was an inspiration for this library, and you'll probably notice the methods are called the same. And So let's start maybe. So we'll start by adding the, I already added the layout or the render transform, but just for just as a for node, and it doesn't used anywhere. So basically we have to do this. And so layout transform will be identity, and that will be the same here. Layout transform. Okay, and layout transform here. All right. So the next step would be to I don't know. Maybe we'll start from the there are maybe the measurement, I think, but I need to check how the where is that? Right, that's a RangeCore. That's the measure core. And probably right, it's a framework here. It's tons of code, and there should be measure core. All right. So basically, what it does, it prepares the information for the transformation. All right. Yes. So it basically uses the transform to calculate the new available size for the node, and then it calls the measure override to measure the entire hierarchy of the nodes, and and then it takes the desired size and it transforms the rectangle again. So as you can see, it uses a rectangle transform with the transform value, which is matrix, and that's the matrix 3 by 3. And yeah, that's what the this method does basically. It also have some rounding and stuff, but we don't need that in here. Basically, have the simplified version of that. And there is also a RangeCore, which also uses this LTD, which is layout transform data in short. And what it does, it where's that? Where is the range? I don't see the there. Right, there's a range override. So it does a lot of stuff in here, but as far as I see, basically it does the same. So it prepares the scaled version of the size. It is not also scaled, but that it could be affected by a rotation, as you can see in here, the bounds changes to. And where is it used? So right, it unclip desired size. That goes to a range size. And yeah, basically it passes the modified size in here. And what it does after, Does it use the LTD again? Yes, it does. But I'm not sure what does the ink rectangle transform does. So the idea is somewhat simple. I should try implementing that in a straightforward way. So it should be relatively simple, but I am not sure if it will work correctly from the first try. So, yeah, indeed, I can. I can increase the font size, but I haven't started writing anything like important, so shouldn't lose any important information. So probably we should start. So at this stage we have the size, available size, and we should transform that. Let's check how the library does that. It has the special function. I'm pretty sure it's this one. Wow, it's quite long. Wow. I didn't check that before, and what it does. My parrot's crazy today, as usual. Sorry for the noise in the background. Yeah, it does a lot of stuff. I'm pretty sure that we can use the simplified version of that, and I already have the method for transforming the bounding box, which would be simplified to use in two-dimensional space, and that will be in math module. No, not this one. This one. And it should contain the... All right, it should be in... Where is that? Should be in AABB, which is axis aligned bounding box. Yeah, so we have this. This method, and it can be simplified to be used in two-dimensional space, which basically the rectangle. And we want to discard the position of that rectangle. We only want to know the size of the rectangle. So probably we could just take this and go to yeah, let's create a local function. And that will be the matrix 3. That will be all right, we don't need that. We need to return the vector 2 f32, and in here we want to take all right, so I want to take the size and the size will be vector 2 52. And also, what else we're missing? So we need to prepare the min and max values, and that will be probably just vectors. min equals to the position. We don't need that, so probably vector 2 default, and maximum will be the default 2. All right. And that will be probably the out min and out max. Something like this. Okay, we don't need the bases. Like this. All right. And yes, we should also decrease the size of this, because we don't need we need only a scaling and rotational part of the transform, which stored in the first submatrix, basically the 2x2 submatrix of the 3x3 matrix, and that will contain the components basically for x and y axis. And as a position, we don't need the position, so that will be the default. And the input minimal value will be in min will be 0, and the max will be the size. We can simplify that later. So right now I want to just transform this method to just take the rectangle that stays at 0 and have the size, the specified size. So I'll go in here, and this will be this, and we should return the difference between the max and min. And what I don't like. All right, that should be beautiful indeed. Okay, so this transform should work now. I hope it will. So basically it will take the yeah, it should take the rotational and scaling part of the transform and modify the points, the extrema points. What noise? You don't hear anything. All right, that's cool. I have a noise canceling filter on the mic, so that's great to hear. That's great to know. All right, so this transform should be, probably shouldn't be in here, because it will be used in multiple places. So that will be transform size. Let's call that like so for now. That will be measure node. Go back in here. Let size equals to transform size. We'll get the matrix from the node. That will be the layout transform. Complains that it is not public, like so. And also, according to the source of the WPF, we need to transform that again, but we need to transform the desired size. So the desired size will be equals to transform size node layout transform. All right, and also we want to do pretty much the same for the arrange node. So as you can see, it also returns the size and gets the size. Basically the same. Size will be equals transform size and node layout transform. And again, it's a bit confusing. Size equals. There's a lot of equals. Yep. So basically that will this method will probably limit the size that was passed in here, but then again we will increase it by using the transform size. If I'm not mistaken, this is done in the WPF, but where I forgot. Where's the measure core? All right, let's compare. So basically it creates that, does this, passes that to here, then the desired size is clamped. All right, it's clamped, that's different. And what else it does? Okay, what does the rect transform? Let's check. There's a lot of code which does not tell me anything. But yeah, it discards position and only takes the width and height. And I goes to unclipped desired size and where it goes again. Clipped desired size. Oh, this code is so convoluted. I also have Sea Lion is just great. Okay, so it is like very good, and that's enough for me to start using it. And JetBrains tools are very cool. So probably I don't know. There is also a project that is called Avalonia UI, which is a open source port of the WPF. It is cross-platform, so it works on pretty much everything. Whereas the C# is available, and it also has this functionality. So, and it is also much more easier to understand. So we could use that as a reference if this won't work. But I hope it will. So probably we can just continue with that. And as a next step, we probably should go to draw module, and that will, this is the place where we render in this everything on this in the command buffer, which will be rendered by the UI renderer late at the last stage of the rendering. So in here we probably want to pass the yes, probably we should create a new transform stack, which will contain the matrix 3 F32. So that stack will contain all the matrices we will use for rendering. So probably we should also create a separate structure stack and combined transform multi-matrix, and the stack itself will be this, and the transform stack will be this. We all need to have the push to put itself, that will be matrix 3, and what it will be doing, it will modify self combined transform with the matrix, and also it will put the same matrix to the stack. And we also need the pop method, which will remove the last matrix from stack and revert its changes from the combined transform. But there are two options we could do. One option is to multiply the combined transform with the inverse of the matrix that is on top of stack, and that will essentially discard the changes, discard the matrix from the combined transform, but matrix inversion is not so fast. So alternatively, we can just maybe recalculate the combined transform from what we have on stack. I don't know which is preferable, because yeah, we probably should focus on the result, and the performance could be fixed later. So top will be set stack pop, and that is indeed an option. So let sum top equals to this. We should do self combined transform multiply to top inverse try inverse. Try inverse should take the what? Why it doesn't take anything as a parameter? All right. That's confusing because the try inverse for matrix 4 accepts the tolerance parameter. Right. Unwrap all default. What the default of the matrix should be identity, right? I'm pretty sure it should, but no. We should probably unwrap or else, and then here we should construct the identity matrix. Identity, so it won't change. So if this will fail, this will return the identity, and this operation will do nothing. So is that correct? So basically, this by default. No, probably should implement what transform stack. And then here we should implement and that should be the matrix 3. The matrix 3 should be the identity matrix, and the stack should be empty stack. What else? That should be enough, I think. I'm still not sure if this order is correct. So basically take the identity matrix at first and then multiply it to another matrix, which will basically give us this matrix. On the next step, we will... Does it even compile? Is it even defined? Let us check. Right, there's something missing. What else missing? Here's the transform stack. Type annotations needed. Why you need that? All right, confused about the types. All right, great. It compiles. That's cool. That's great diagnostic message. It tells us that we have done something wrong, and field is never read. That will be fixed, and that will be fixed too in just a second. So basically, what we want to do is to override this push method, which will modify the position of the vertex, because every vertex it is in screen coordinates. So we basically need to do the multiplication on the CPU. We want offload that to GPU. That is a bit that could slow down things, but not so significant, because the amount of stuff on screen is not so big. So there could be like up to maybe 10,000 vertices at a time, so not a big deal. any CPU can handle that. And also the multiplication with the matrix 3. Where is that? With this matrix 3, it is with any matrix 3, it is a bit cheap. So the matrix 4 requires you to have like 4 scalar products between the rows of the matrix and the vector. So that should be not so CPU intensive. And what else? I'm pretty sure that, yeah, the drawing context could be also implemented. Right, it is implemented for the clipping geometry, and it's implemented in here. So probably want to do this for 2 implementations. And vertex buffer, or we could override this vertex buffer. We could create a separate structure, proxy structure, which will override some of the methods. Like the push method will require the additional parameter, which will be the matrix, transformation matrix. So what is that? But probably, yeah, let's start from simple. This can be implemented manually. Push Vertex raw. And that will be this, and we don't need this anymore. Like so. Where is another implementation? It is in here, between this. And also yeah, let's go to the implementation of this, and basically we want to modify the position. Self transform stack, the combined transform, and that will be transform point 2 and point 2 from this vector ports and vertex position, something like that. And if it compiles, we should not that the call, it should probably do the same for clipping geometry implementation, not this. This is like the copy paste code, but it is okay for now. I'll change that later. What do I don't like? All right, and yeah, that should be enough, I think. Let's check if it compiles in the editor, and nope, it does not. Because why? Yes, because I forgot to transform stack. We should have this here too. And clone is not satisfied. It's easy to fix. Clone. What else? He complains about the private type and public API. Welcome. Right. Let's check. Let's check if everything works as it should. It shouldn't change. The current changes shouldn't change anything, but the performance could be a bit less performant now. So because of the matrices and stuff, but the layout should remain the same and nothing should change. Is it the case? Nope, it isn't. It is not. Something is broken. The text is broken. What else is broken? The menus are broken. All right, let's go to here. Ah, right. It could be. Yeah. It seems that the default value of that stuff. No, it should be identity, right? Identity, yes. And where is that initialized? Only there. It should be initialized only there. All right. Seems that this transform size does not work as it should. All right, let's find out why. Probably we should write some tests. Okay, let's do that. Let's put that down the bottom and check that probably here. And test transform size. That will be test. All right. As an input, we will input will be vector2, not this vector2, this vector2. That will be 100, 100. Transform will be matrix 3 identity. And then we will do transform equals to the input should be equals to transform size. Transform size will be transformed in the input, and the matrix will be our transform. And then here, what else? Yes, it should be equals to the transformed. Let's run this test. All right, it will take some time to compile. Even more. I'm not sure if I will be able to see the enough code on screen, but I will try. 18 will be, I don't know. Is that better? It's like I'm sitting right in front of 27-inch monitor, Quad HD 27-inch monitor, and like there's a half of a meter between me and the monitor, so that's not a big problem for me, the small text like this. But on the devices with the full HD monitor, full HD resolution could be like the pain to see the text on them. So it seems that the tests are passing, but it is very weird that this stuff has changed. So okay. All right, so at this point, we'll probably messing up something in here, maybe. So let's do the assertion in here that size equals to let new size be equals to this, and the size will be equals to new size. Oh, no, what am I doing? Completely. The old size. I should be called the old size. And that will be this. And the size should be equal old size. That's just for tests. And also, yeah, let's try that. And I'll be in the editor. Directly in the editor. I also wonder if this is required, because we could just use the render transform, because the heat test, when you click on some control element on the screen, it is performed using the stuff that is passed to renderer. So, right, it's failed. So it could be enough. Let's see. All right. It seems that it fails on the edge cases where you have the transform, not the transform, but the size of infinity, or not a number. So in this case, let me explain why there is an infinity or not a number. So these values are okay in our conditions, because so the max size could be infinity. It by default it is infinity, but also the width, the default value for width is not a number, so it is called none, not a number. And that basically tells that there is no width set. So that could be replaced by an optional F32, but yeah, why not use the special value that the floating point numbers offer? So probably we should modify that to use why there's 32. 23. When am I smoking? Am I blind or something? Where is that code again? Oh, all right, it is in here. So yeah, that it should not return 23. It's like, it's very weird. Where does it take it? All right, it could be from here, because any method that any operation with not a number is always false. So basically, not a number will like none is not equals to none. That it is property. So basically, that will be true, even if it is confusing. So that's the nature of the floating point numbers. You mean to split the screen into two portions, and I just used to use the left side. I usually just have it split, and there is something else on the right side. The screen is a bit huge, so and I'm sitting too close to it. So probably in case of size equals to and not a number, we should do this. So this will be new size, and if size dot x is none, then we should probably return the vector, and if it is none, then we'll return the none. F32 none, else we'll return the new size dot x, and then here we'll return the same for the y, and I don't need these parentheses. I sometimes write the code in C++, don't ask why, and it is sometimes leaks into Rust code. And so that should work now. It should preserve the F32, the non-values. I hope it will work, because I don't have any time in the world to debug that. And the test is failing for some reason at the same place in here. So the right. Oh, I misread the code and misread this. This message basically tells me that the right is the old size, and it was this, but I got this. Ah, god damn it! It seems that there's a bug inside of this transform size, which gives me then not a number. And where does it? From where it could come? So probably we don't need that. Don't need that. Don't need this. And the old size is on the left. On the x it is infinity, and on the y it is 23. Not the 32. Why I keep saying that? Like swap the numbers in the memory. Right. Hello. So this is the transformed. No. This is the old value from here, and on the left it is the new value that was from this method. Not a number. Usually the not a number appears when you try to divide by 0, but there is no division in this code. This is multiplication. Max minus min. AB. I wonder what's inside the bases. Should be full of zeros and ones. So the min is 0, 0, and the max is 0, 0, 2, and this is 0, and this is the size. What if I multiply something by infinity? What it will return? The infinity again? Or I can't remember what it will return. Yeah, let's try that in here maybe. Probably should return the infinity, I think. So f32 infinity and f32 infinity equal multiply by 2 and run that test. It's almost slow to compile. These special values are always the pain to handle, especially when they come up in some complex calculation. Oh my god, what? Why I have run the test of everything? That's just freaking stupid. Alright, it should return to infinity as I was thinking before. Alright. So why it returns? Alright, let's emulate this in here. So basically we'll put that in infinity and test that. Will it pass or will it fail? We'll find out that. Alright, it fails. And that creates the not a number. Why? I have no idea. So the size is in the our infinity is in this value. What interesting is that it messes up the opposite coordinate. So we have put the infinity in y, and that started to messing up the x, which is probably from here. Oh my god, this floating point arithmetics is so confusing. So annoying. Alright, you know what? I will leave that to the off stream because I don't want to spend tons of time trying to debug this shit, and we'll probably just comment this and we'll just use the rendering transform because that is much simpler. I don't give up. Don't even think that. I just want to focus on this after the stream. And I probably will say something like very obvious, but doing something on stream is a bit stressful. So I want to be in much better conditions than I'm right now. All right, everything works as before. That's cool. So now we can try. Now we can continue on the rendering, and to do that, you'll go into the draw node method. It should be somewhere in the library. Draw node. All right, and in here. And here we should probably, yeah. So as you can see, it pushes the opacity for disabled nodes, and we should do pretty much the same for the transform. Transform post. And we don't need that flag. What am I doing? So basically we want to do this drawing context push not this. It is not available because it is not public, like so. Drawing context, transform stack, push, and then here we probably want to push the combination of two matrices, which will be the node layout transform that is multiplied by render transform, and after that we probably need to drawing context. No, not this. The transform stack pop. And that shouldn't change anything again, because the matrices are identity matrices, so there won't change anything when multiplied with vector or matrix, something like that. So the picture should remain the same. Okay, and that's the case. That's cool. And now we can check if it works by going into the canvas and get rid of this. Don't need that. Need this. And instead of modifying these values, of using these values in here, we want to create not the create, but set the transformation in at the moment when we changing either the view position or the zoom. And to do that, probably what we should do is to create a separate message that will pass the new transform into the widget. Where is that? Yeah, that's the list. It's pretty huge. And that will be the layout transform. Fix 3. And render transform. Layout transform. Layout transform. And that'll be like this, matrix 3. And the same for render transform. Render transform. Okay. Now we need to handle these messages, and there should be a special method for that, and it is in here. That's correct. Message layout transform. So in here we want to check if self layout transform not equals to the new transform. This is very important step when we check if it does not equal, because the invalidate layout, which we will be calling in here, is super complex. So if we'll blindlessly do this, then if we will pass the unchanged transform every frame, then it will call basically this invalidation, and that will probably ruin the performance of the UI if you have something complex. So that is important. Probably we should compare like so. And for the rendering, for the render transform, we don't need to invalidate layout in this case. That's because this just affects the rendering, and in this case we don't even need to compare anything, so set that to directly. So right now the UI is able to receive such messages and respond to them correctly. So at this point we can go to canvas again and create a few functions in here for the canvas, and one of the function will be it will be probably the update transform, which will get the self. Yes, probably yes, the one method is enough, and in here we should create the new transform. So the transform will be the matrix 3, which will be new scaling self zoom multiplied by matrix 3 new translation, and the translation will be self view position. I will take reference, and in this case we also need to take the user interface as a parameter and send a message in here from here to widget message, the render transform. We will use the render transform for now. I will fix the layout transform, and that will work. That will be changed when it will work. So, and in here we will be using the help handle, message direction to widget as usual, and the transform. Yeah, I hope I did that in correct order. So we want to zoom first and then translate, not the translate and zoom, because that is very important. There will be two different matrices if we will swap this. They will not equal, and that's the nature of the matrices. something new for you if you didn't know that before. And in here we want to we don't need the invalidate range. We will just need this update transform and call that with the UI, and that will be for zoom in and view position, like so. Let's check that. I hope it will work. Yeah, it is not used. And it will be used, I hope. Okay. All right, it works, sort of. Wow. What a trippy effect. What the hell is this? Probably I messed up either the order of the transforms. So maybe this. I can't remember the correct order of the multiplication. So that basically depends on how the I don't know how to describe that. So the order is important. That's what you need to know. No, it's still not the issue. So let's revert that and go to the drawing functionality and the push maybe. So I'm curious if this works as intended. So that might not work as intended and ruin everything. So yeah, let's do this. Since we have just one matrix, so we probably want to do just this for tests. I just want to know if that will work. That will work correctly or not, or maybe actually you know what? It could be the result of flipping issues. Yeah, that's probably the case. So it's not so simple. Yes. Yeah, exactly. Exactly. That's the case. So let me show you that. There is also clip-in method, but where is this? I can't remember. All right, it should be maybe in here. It's in here. So it should be in a draw command. Where is the draw command? All right, yeah, the clipping bounds. I should transform the clipping bounds too, because when I transform the geometry, the clipping bounds remains the same on the screen. So when I'm doing let me revert that. So when I'm scaling the geometry, the clipping bounce remains the same. So even I like change the size by 2, the clipping bounce will still be the same, and that will be even worse if if I have something not at the origin. So if I have the origin at this point, then the scaling will not mess anything. So this will still render. But if I have this at some position that is not at the origin, then this will move somewhere to this when I scale. And since the clipping rectangle is in here, it will clip the scaled rectangle away, so we won't see anything. And that's basically what happens in the editor right now. So I hope I can demonstrate that. So slow to compile. Yeah, let's move that. Yeah, as you can see, when I move, the clipping rectangle remains at the old position. So we need to transform that too. And this is where we need that function again. This function again, but in this case, it should be like fully implemented. So so we basically need to have that in take that from here, go to rectangle, and implement that method in here. I wonder if it already have something like this. No, it doesn't, and that's a bit annoying, but okay. So, and as a matrix, we'll be using the matrix 3, and it does not have the min. It does have the position and the size, but that's okay. The position, as far as I remember, the position is the top left corner, and the size is basically defines the width and height for the rectangle. So as a position in here, what we will take, so that will be the T. The basis, we don't need that. And yes, probably we should do the same as before. Mutable equals to right. So let's remember where the translational part in this 3x3 matrix is located. So let me do this real quick. What are you doing? Oh, you motherfucker. 3, 4, 5, 6, 7, 8. So we need these 6 and 7, and to bases 7, and the same in here. All right, and that should be 2, 2, and that will be transform min, transform max. And for the main will be self position, and the max will be self right bottom corner. No, right bottom corner. That is correct. Right bottom corner. So that will be the max, and this, and so the rectangle will be returning is, so the position will be vector 2 new. No, not this. This, and as a size, we will take the transform max minus min. Let's check if that compiles. That should compile. Yes, it compiled. It's cool. And we should go to draw. I should go to draw and go to there should be yes, this stuff. So this clip bounds should be transformed. Transform. All right. Clip bounds transform by a self combined transform. I hope that is enough. Right, let's see. And yeah, that's enough. As you can see. Whoa. What the hell? Whoa. That's trippy. I don't know why it is allowing me to move that. What the hell? To move that away outside of the bounds of the window, which is super confusing. But I'm really happy that it works. However, this is not clickable, which is a bit annoying. Let's check if it is clickable when... Yes, it does. And I can move that. And if I move... Why can't I... Alright, I can still click inside the bounds, and that will be selected. If I move that... This... Alright. Alright, okay, so it seems that something else is not transformed, which should be transformed. But what is it? Let's check. There's also bounce. So this is for scissor test, and that is global bounce, and that should be also transformed by the transform we have. So how will be bounce, transform self, transform stack, combine transform. Let's find out if it works. I doubt it. I'm not sure about this, but we'll find out. That is somewhat confusing. All right. Wow. But it is clickable? No, it's still... I wonder why this happens. Where should I click to say? Right. So confusing. So the click bounds, where they're calculated? Let's see. Probably the click bounds. Let's find out if let's check any implementation of. Yeah, that is okay. So self click bounds, and what is that? This. Check that. Calculate click bounds. And what it takes the screen bounds that was provided by the layout step, and it's basically multiplied. All right, it's clipped by the parent bounds. Okay, that makes sense. And calculate clip bounds. Yes, that's recursive. And also, basically that should be in the clip bounds are given in screen coordinates. Okay, that is the problem. So we need to somehow operate in in different coordinate system. And today's coordinate system, I don't know what that should be. So that is working for sure, and that's cool. Let's see that again and try to figure out in which coordinates we should work. So if I click, that works. The scale and the offset remains the same, and if I move that works again. And if I offset that to somewhat small value, it seems that So the clipping bounds are ruining ruining everything right now. And it seems that this happens because I move the clipping bounds in screen coordinates by this amount, the offset from the left of this, and that basically moves that outside of the coordinates of the window, or not the coordinates, but the bounds of the window. Problem. So probably I should change the way how the clipping bounds are calculated. Because maybe I also can try to maybe yeah, probably I shouldn't modify this in here. That's because we are receiving that from external, and that should be calculated outside. So let me check where that is calculated again. Yes, in here. So right. So that's the place where this should be performed. So instead of doing the multiplication in there, I should pre-calculate the maybe the global transform, combined global transform of the node, which will include the transform of the parents, and I should probably not using the screen bounds in here, but instead use the local bounds and multiply that by the chain of the transformation from the parents and the node itself, and then clip it by the parent bounds. Oh my god, that this task seems to be just a bit harder than I thought, and this is, it seems to be a long task. Yeah, probably I should do something now, something off stream, because that will require a lot of thinking, and it's probably not very interesting to watch. Yeah, yeah, and also the time. I need to go in 10 minutes, so probably I will end that now, and I will like try to solve that problem off stream, and once I solve that, I will explain everything on the next stream, what I have done, and yeah, I will keep you posted, so you will understand what what my approaches were, and you basically won't miss anything. So yeah, probably that's it for today. Maybe there is nothing nothing fancy today, but yeah, so that bug is returned. I will fix that. So yeah, thank you for watching, guys, and I will be back when I solve that. That will maybe take even like a few days, maybe, and probably I will work on a separate branch because yeah, I will not break master, and yeah, see you on the next stream, guys. Thank you for watching.